we're going to take a look at polar coordinates. Now, it's normal that you might never have heard of polar coordinates before unless you've taken a trig class. So this will be quite common. So we're really going to begin at the beginning, the basic of what polar coordinates are. So around middle school, I would say, you learn about the rectangular coordinate system. And the rectangular coordinate system is a system where we graph points. And the points that we graph is an ordered pair, x comma y. And so in the rectangular coordinate system, the horizontal axis is called the x-axis. So the x-coordinate is how much you go left and right. And the y-axis is the vertical axis, and that's how much you go up and down. And normally you go to x and then you go to y. That's just how we plot the points. But you could also go to y and then x. And the point in the middle is called the origin. It's 0, 0. The rectangular coordinate system is a gridded system. The polar coordinate system is a circular system. So there are two things that are important about the polar coordinate system. The first is at the point in the middle, which is normally called the origin in the rectangular coordinate system, is called the pole. So the pole is the origin. And then the other thing that's important is that this axis here is called the polar axis. So the polar axis is the positive x-axis. And so when we graph in the polar coordinate system, our points, our ordered pair, is actually going to be r comma theta. And pretty straightforward, theta is going to be the angle in standard position. So everything that you already know makes sense. And that's why the angles are measured the way that you know the angles, pi over 6, pi over 4, pi over 3, and so on. Because at the polar axis, it's 0. And then r is going to be the distance from the pole, the distance from the origin. Now, normally when we graph in the polar coordinate system, which you're about to see in the next question, we normally first go to theta and then we go to r. And so that kind of is different from when we do x comma y, because as I mentioned before, normally you go to x and then you go to y. But here in the polar coordinate system, you're actually going to do the right one first, and then you're going to do the left one. So first theta and then r. Okay, let's take a look at how that looks like. So here's a blank polar coordinate system. So again, like this is going to be 0. This is going to be pi over 2. This is going to be pi. And this is going to be 3 pi over 2. And then in quadrant 1, right, this is going to be pi over 6, pi over 4, pi over 3. Okay, so it looks very different than the rectangular coordinate system, which makes sense. It's a different system. So here, this is a circular system. So we're going to plot the following points. I believe I have 6. Okay, so let's plot the first one. So the first thing we're going to do is we have 3 comma pi over 3. So you're going to go to pi over 3, which I already labeled, and then you're going to count a radius of 3. So 1, 2, 3. Now, if the circles are not measured, it's assumed that they all have a radius of 1, but you could label them as you wish, just like in the rectangular coordinate system. Okay, the next one. Now the r is negative. What does that mean? Okay, we're still going to go first to the angle. So 5 pi over 6 is the angle in quadrant 2. But when the r is negative, what that means is that instead of counting 5 towards 5 pi over 6, you count 5 in the opposite direction. So you count 5 in the line across from it. So 1, 2, 3, 4, 5 would put us right here. So that's what r being negative means. It just means that instead of, it's like, think about you walking forwards and you walking backwards. So you go to the angle, and if the r is positive, you walk forward. And if the r is negative, you walk backwards, if that helps. Okay, let's go to 4 comma negative pi over 3. Okay, negative pi over 3 means that the angle is clockwise. So negative pi over 3 is down here. And the r is positive, so you go directly to negative pi over 3. 1, 2, 3, 4. Here's 4. Okay. 5 pi over 4, negative 1 comma 5 pi over 4. So first, let's go to 5 pi over 4. 5 pi over 4 is the angle in quadrant 3. But because r is negative, I got to go backwards. I'm going to walk backwards. So I'm going to go here to pi over 4. All right. 5 comma pi. Okay, well, pi is the axis angle. And then because r is positive, I just walk forward. So 1, 2, 3, 4, 5 would put me right here. And let's see, pink. And then I have negative pi over 2, negative 2. So negative pi over 2 is 3 pi over 2. They are the same angle. And then negative 2 means that I'm going to walk backwards. So I'm actually going to walk towards pi over 2. So here's my point. So here are my 6 points. So again, first you go to the angle, whether that be counterclockwise or clockwise. And then you go r. So positive r means goes forward. Negative r means goes backwards. All right, so we're going to be plotting a lot of these over the next few videos. The next thing we're going to discuss is multiple representation of a point. And I'm actually going to do this using an example. So I'm going to consider 3 comma negative pi over 2. Now negative pi over 2 is down here. And if r is positive, I go right here. Now, the reason that you have multiple representation of a point is because you can have multiple points that are graphed exactly the same. So for example, because negative pi over 2 is the same thing as 3 pi over 2, 3 comma negative pi over 2 is the exact same point as 3 comma 3 pi over 2. Because again, the angles are the same. And that's going to happen because in a circular coordinate system, you have coterminal angles. So you can add 2 pi or you can subtract 2 pi. So for example, here, I added 2 pi. Instead, what I could do, instead of adding 2 pi, I could subtract 2 pi. So I would have 3 comma negative 5 pi over 2. This would be the exact same angle. Negative pi over 2 is the same as negative 5 pi over 2. They're both 270 degrees. So it would be the same point. And I could keep doing this. I could keep adding 2 pi. I could keep subtracting 2 pi. And the point graphically would be the exact same. That's one way of having multiple representation of a point. So that's one. The other way, which is a little bit trickier to see at first, is I can think about this angle up here. Directly across is pi over 2. Now, we know that if we make r negative, then we walk backwards. So instead, what I could do is make this angle pi over 2, the one directly across from it, and make r negative. What that means is I would go to pi over 2 and then walk backwards, which would put me at negative pi over 2. So these points are the same. So what I did here is, remember, directly across is an angle of pi. So I added pi. What I could do instead is I could subtract pi. So that would be negative 3 pi over 2. And the r would be negative, because remember, I'm across. So how do we create a little general formula for this? Very simple. If you have the point r comma theta, the way that you do multiple representation is 1. If you want to keep r the same sign, then what you do is do theta plus or minus 2 pi. So if you want to keep r the same, you have to find coterminal angles. So you add or subtract 2 pi. The second way, if you want to change the sign of r, that means that if r is positive, you make it negative, or if r is negative, you make it positive. Then you have to go across, so you add or subtract pi from the angle. So here is our little formula. Let me do this actually. So this is how we're going to do it. And now we're actually going to apply it to different. I mean, we did it with 3 comma negative pi over 2, but let's do it with another one. And I think I might have 2 examples actually. Oh no, 1 example. Okay. So we want to write 3 other representation of the polar coordinate. We want to change the sign of r at least once, and we want to graph it. So you can graph it at the end or graph it first, whatever you prefer. I normally graph it at the end. So my point is currently negative 1 comma 7 pi over 6 equals. Okay, I'm going to keep r the same, and then I'm going to add 2 pi to 7 pi over 6. And again, if I want to keep r the same, I have to add 2 pi. So that's going to become negative 1. 2 pi is 12 pi over 6. So that's going to be 19 pi over 6. So that's one other representation. Okay, another thing I can do is keep r the same and instead subtract 2 pi. So that's going to give me negative 1, comma, 7 minus 12 is negative 5 pi over 6. Okay, I could also change the sign of r and then add pi to it. If I change the sign, I can only add or subtract pi. So that's positive 1. Pi is 6 pi over 6, so that's going to be 13 pi over 6. Or, I'm going to do one more. I know it only asks for 3, but it doesn't hurt to show. 7 pi over 6 minus pi. I change the sign of r. I subtract pi, which will give me 1, comma, pi over 6. So this point and all of these are the same point. That means that whichever one you graph, it's the exact same point on the graph. So sometimes a question that students have asked me is, well, which one do I graph? It's all the same point. It doesn't matter which one you graph. It's going to be the same point. So you kind of look at which one is the easiest. For me, the easiest is the last one, 1 comma pi over 6. But again, that's a preference. So pi over 6 is here. And then 1 would be the point right here. And there it is. And then again, if you graphed it using the first one, this would be 7 pi over 6. But because the r is negative, you would walk backwards. So this is how you write multiple representation. And again, this is important because we're actually going to be graphing equations. And you're going to see that when we graph equations and we're creating points, sometimes you're going to be graphing the same points. And that's normal because there are multiple representations of the same point.